Well, hi, this is John from Homework Help Now, and in today's brief tutorial, I'm going to talk about introductory statistics. Specifically, I'm going to focus on basic symbols in statistics. And if you're new to this study of statistics, then this is a great place to start. Knowing the symbols, recognizing them, is really key to understanding the equations and also some of the central concepts in statistics. So we start with the first pair. We have a capital N and a lowercase n. So what is the difference between these two and a similarity? Well, to answer that question, we have to know something about a population versus a sample. So let's look at an illustration. On the left, we have the whole wide world, a population of 7.4 billion. And we're going to pull a sample out of this big population. And that sample is going to consist of 320 million people or data points. If someone was to ask, well, what are the data points in the population? We would say 7.4 billion. And we would denote that with a big N or a capital N. N equals 7.4 billion data points. Same thing with our sample. We would denote our data points of 320 million with a small n equals 320 million. So big N, population data points. Small n, sample data points. Easy enough. Moving on to the second pair, we have a symbol that is a Greek letter called a mu, and below it we have a symbol known as an X bar. So again, what is a similarity and a difference between these two? Let's look at an illustration. So here again we have our population versus our sample. Again, we pulled the sample out of the population. We have 7.4 billion data points in the population and 320 million data points in the sample. Now suppose we wanted to calculate a mean of the 7.4 billion. Well, we could do that. Mean should sound very familiar, and it's pretty much a simple calculation. We know that we would add up our data points, and we would also divide that number by the number of data points to get an average or a mean. You do the same thing for your sample. The difference between the two here is in how they're denoted. For population, we have the mu. That will equate to the mean. And in the sample, we have the X bar, which will be the mean. So in terms of symbols, again, mu, population mean. X bar, sample mean. Moving on to the next pair, we have a sigma squared, and we also have a lowercase s squared. So a difference and a similarity. Here's our population and our sample once again. We have our mean population, mean sample. And now we're in a good position to calculate another type of measure called variance. And variance is essentially the difference of each individual data point from the mean. So it's a measure of central tendency. And there's a number of ways we can calculate variance. One of the easiest ways is if you have the data in Excel, you can use the Excel function to calculate it. So suppose I have my population variance data here as shown. I can easily do equals VAR and then look for the VAR.P, P for population, double click, highlight the data, enter, and there it is. I can do the same for my sample variance, equals VAR look for the .s for sample, double click, highlight the data, click enter, and there is your sample variance. So my population variance, 631.11, my sample variance, 31.5. So again, in terms of symbols, sigma squared would be my population variance. My lowercase s squared would be my sample variance. So at this point, you're probably seeing the pattern. Population versus sample. So in our next pair, we have a plain sigma without the squared and a plain lowercase s. So let's see what that means. Back to our example. Now we have our mean of both population and sample. We have our variance of both population and sample. And now we're in a good position to calculate another measure, and that's the standard deviation. So again, there's a standard deviation for population, and there's a standard deviation for mean. And there's a few ways we could calculate it, but the simplest way, one of the simplest ways, is simply to take your variance and to find its square root. If you can do that, then you can calculate very simply standard deviation for both population and sample. Or if you'd like to use Excel and you have the data, we can use the Excel functions that are available. You simply do equals st, you can stop there, and you'll see stdev dot p, p for population, double click, select your data, click enter, there it is. Do the same thing for your sample standard deviation, equals st, and stop, stdev dot s for sample, double click, select your data, enter. Now I have my population standard deviation 26.59 and my sample standard deviation 5.99 or 6.0. So again, in terms of my symbols, sigma without the square would be my population standard deviation. My lowercase s would be my sample standard deviation. Now for the next set, I'm actually going to look at sets 5, 6, and 7 together in the same context. So HO and HA, a concept we use in something called null hypothesis. A null hypothesis is essentially a formal way of stating something that you're trying to prove or disprove. Could be an assertion, could be a guess. Essentially, the null works like this. You always state the negative first. So suppose we want to test the relationship of something, or perhaps we want to test the mu of our population because we believe that the mu of the population may be 30, for example. So if we believe the mu of our population is 30, we state the null as follows. HO, our mu, is not equivalent to 30. We always start with the negative. Null for no. Null for no. Then we state the alternative, which is mu is equal to 30, just what we started with in the beginning. This is our null hypothesis. So in terms of symbols, HO would be the null or the no, and HA would be the alternative. Now the next three symbols should look quite familiar. But again, understand that we're using these in the context of null hypothesis. So again, when I do my null, when I state it, I state mu is not equal to 30. That's my null. Now, how do we actually test our null? How do we know if we should accept the null or reject it? Well, we go through the experimentation process, and at the end we have data that we could use, we can compare it, and we can state the results. And those results will tell us if we should accept or reject the null. So specifically, we use something called a p-value, and we use something called an alpha, or level of significance. At the end of our testing, we compare the p-value and the alpha. If the p-value is less than or greater than the alpha, or level of significance, then we reject the null hypothesis. If our p-value is greater than or equal to our alpha, or level of significance, then we've really failed. We failed to reject the null. Now note that the alpha can be a value of 0.05, it can be 0.01, it really could be any value that you set. P-value is defined as the probability of finding your observed value or something more extreme in the results when the null hypothesis, or your HO, is true. And alpha, again, a level of significance, you can set that at 0.05, 0.01, or any other level. And that really does speak to your confidence with type 1 or type 2 errors. And that's a concept we'll get to in a different video. But for now, focusing on symbols, we'll use the not equal to in the context of null hypothesis. We'll use the greater than or equal to in the context of, again, null. And same thing with less than or equal to in context of the null. Now P will stand for p-value, as we saw in the example, and then my A or my alpha will be my level of significance. Last set, we have X and we have Y. Now there's a concept in statistics called simple linear regression. Not a concept we're going to talk about in this video, but we will in future videos. Right now I want you to focus on the Y and the X. What are they? What do they have in common? What is their difference? Well, the one thing that they share is they're both part of what we call a simple linear regression equation. And my Y is essentially something called my dependent variable. It's dependent because we're waiting to see a response out of Y caused by X, which is the independent variable. So essentially the X will act upon the Y to cause a response from the Y. So again, dependent variable, independent variable. And that's it for this lesson of basic symbols in statistics. Hopefully you enjoyed this and you got something out of it. Thank you and see you next time. Take care.